of a ceramic compound that really does the action. It becomes superconducting at liquid nitrogen temperatures, and that's it. They cover it with sapphire just for protection, and that's it.
What's
So
the material made of that's superconductor?
it's metals and oxygen. It's yttrium, barium, copper, and oxygen.
Okay.
That's it.
Is this a unique mixture that was developed in Israel?
No. It's I think the most commonly researched superconductor because it's non-toxic. It's relatively high temperature superconductor, and it's quite common. It's not used in any application yet. I think we're gonna start seeing it in tapes, flexible tapes. Thank you. I got myself some water. Thank you.
And what happens is
Wait. We're gonna need new aluminum foil. So.
And this is a half a micron. That's half a micron thick.
Yeah.
And how much thickness do you need to be able to raise a car off the ground? In theory.
A few millimeters in theory.
Okay.
Of course, if you have larger area, then you don't need the 4 millimeters. It's a function of the area itself.
Okay.
So if a car is 1 meter or 1 meter approximately, so you need much less than that to levitate a car. But still, it's difficult to make very thick superconductor.
Okay.
Technologically, we're still not there yet. So.
And when you're talking about superconduction, you're saying that wafer thin product at the temperature with liquid nitrogen is stabilized so that electrons are not traveling from one atom to another?
What do you mean by traveling?
In other words,
They're not jumping from one state to another.
Yeah.
Yeah, that's it.
Okay.
Yeah. So it's not just that. They're trapped in a single state, and the next available state is far, far away. Otherwise, they would jump.
Right.
Because it's not absolute zero. They still have temperature, so they have thermal energy. So if it would be they have many energy levels, then they would jump because of their energy. But they can't because the next available step is far, far away. This is what makes superconductors so unique. Not every material becomes a superconductor. Okay. So the explanation is simple, but there are still unique conditions to make a material superconducting. So you have to remember that. Yeah, I was asked to make a stronger.
So if it works, it means that it will be able to be farther away from the magnet?
No. And this is because the magnetic field disappears.
It's not exactly what I was asking. Because what I was asking was
the
that.
other one. The other one just asked.
Because that is. There's layers in between the two substances. I would like them to be literally on top of each other. But okay, I just want to be clear. It's not exactly my question.
Okay.
If you would like to.
If they were on top of each other exactly.
Then maybe it would be more of the effect. I don't know.
It's linear. In principle, it's linear. So
Now we have a buffer in between. I don't know.
if you have 2 layers, then the locking is twice as
That's
strong.
what I would think.
Yeah, and then you'll be correct.
Oh, so we're not going to be able to move it as well. It's gives me a lot more friction moving it.
It be a much more resistance to take it out of the rail or to move it sideways, but not along the rail.
Yeah.
Okay, so you see, I put more sponges inside, so
Okay.
it will have more volume for more liquid nitrogen. It could hold more time. I've never done this, by the way.
Oh, so let's see.
So
Experiment.
let's see.
That's what experiments are about.
Yeah, every time I do this demonstration, I do something new. It's amazing. Maybe it won't work. I don't know.
All right, Hinez Magia. It's gonna be awesome. Let's do it.
If it doesn't work, I blame you. Okay?
Okay.
I have someone I can blame.
The Jew is the scapegoat. Whoa, what a new thing.
Doesn't work. I'm a Jew as well.
I think. No. Daikra.
It's actually
Yeah, I know.
difficult. It would, if you can't comfortable, burn your finger.
Well, no, I mean,
I touch
he
it.
touches
You
it.
go to the dermatologist and you review that.
Yeah, you can touch liquid nitrogen. You just have to do it. Can I take this?
University of Minnesota taught us that obviously it make you a lot of money. Like practice, like taking off.
You have no idea.
You just put on a Q-tip and you go.
Yeah, $130.
So, right. Only in the United States.
Trying to fill it with liquid nitrogen, so it stays.
It doesn't work as well.
It doesn't work at all because it's still warm.
Yeah.
And because we stacked 2 layers and the liquid nitrogen has trouble getting inside. So it takes more time. That's basically it. And by the way, so it's like I said before, it's like a switch, it's an on-off. Above a certain temperature, nothing works. Below a certain temperature, everything works as expected.
Ooh.
Yeah, it's working. It's strong. I can feel it. It's really strong.
Yeah, look at that.
And because it's so strong, I can, without
You can
any,
send it to
I can
me, too?
move it in much quicker, and much higher speeds because it's locked, stronger.
You can put another one at a greater height off of that and send it the other direction, no problem.
Yeah, I could do
Yeah.
that, but I don't have another one.
Right.
I just have the small one.
Yeah.
I could do it
and-
with the
so
small
wait,
one.
but we had the other question. So what was my collision question?
Yeah, this is a different
But we have to
question.
rip them apart. We have
Yeah.
to take them apart for that. Okay.
That was very nice. It worked.
But the problem is now that the liquid nitrogen only touches the top one, so the cooling is not as effective.
Okay.
This is the problem of the cooling itself and
Well,
not
you
the
could
stack.
turn it over.
Yes, but if I turn it over,
The locking mechanism.
the liquid nitrogen just would spill away. Just spill.
It's going through that hole.
I know that.
I'm trying just to fill this with.
Yeah. We just
You know, these are technical questions you have to solve in
Well, there's
every
one, it works a lot more.
configuration. So.
goes back.
Yeah, but it goes back and forth for a lot longer than you would expect because of conservation.
That's even
So
higher.
sign-
Here, it might be higher. So
Okay.
you see, I think this is a world record.
All right, text me.
It's very high. And by the way, you see it's wobbling. Why is
Yeah.
it wobbling? You know,
No.
because when you get farther away, the magnetic field really disappears, almost disappears completely. So the magnetic field here is very, very weak. So the locking is weaker, so it can rotate.
Could you
it can
lower it
move.
down?
Yeah, I can. I can push it towards the magnet, and then it will be much stronger. I can feel it. See, I can.
Oh,
See?
Can I touch it?
Pressing that down?
Yeah, I'm pressing
moving
this
the
down.
actual-
right.
I can move the whole. You see? Because the locking is much stronger.
Can I touch it?
Well, that's
Yeah,
why.
and now it warmed up. Because
He literally went like that.
Pushing it without
No,
actual
because
physical contact.
there are 2 layers.
He was using magnetic
and they
force to
act
move
like
it.
an insulation.
That's so cool.
So the top one insulates the bottom one. The bottom one doesn't get liquid nitrogen.
Enough.
Enough liquid nitrogen at all for that. It covers everything.
But
The-
how much don't you
What
need
we
a
can
lot?
do, I have another
Never took one.
another thing we can do. Okay, let's do it another. Let's do another experiment. Okay. Do you want to make the circles?
Just the bookstore. Oh, she's gonna need to store it.
What we can do is we can do another thing. We can make
Yeah, but it's very good.
for the levitation itself. So probably in the future trains.
There you go.
Yeah, that's the application. Sorry? Yeah. Yeah. Yesterday someone suggested using it for cameras. For making movies, you have cameras. You have to sometimes drive on a rail to make to film some action scenes or something. So you can make rails and the camera floating on top of a rail.
Is that big enough?
No, I think you need to do bigger. you're fired.
Make it this
The advantage of the camera flowing over the rails is that it's
Do
steady.
you have enough? You can use all the aluminum foil you need. Right? Don't be cheap. Sorry?
The camera floating over the rails would mean that it would be steadier. What is the advantage?
It will move smoother without any friction. So you can move it much easier.
And you get a steadier photograph, steadier picture of
Yeah,
it.
yeah. You don't have any bumps and
How many times its weight? I think in Penn Talk you mentioned, I don't remember. How many times its weight can it carry?
So in TED, I did a calculation, and it turns out it can hold 70,000 times its own weight. Yeah, it's amazing. It's very strong. Maybe I can do with no. Give them. There are two, right? Yeah.
How much weight could one micron, like how much of these two, how much weight could this probably hold?
A few hundred grams.
Like a pen.
Not even enough.
More than a pen. No, like a bottle or
So much
something.
cooling.
I can levitate this bottle.
Continuous.
Maybe this bottle, yeah, probably. It depends on the magnetic configuration as well. No,
So could two
here
of those hold more though?
we have less magnets than here. Here we have double layer. So on this rail I can levitate this bottle for sure. On this rail I'm not sure. So it depends on the magnetic field strength and also on the yeah. So I did a different thing. I took two films and I put the sponge inside. So
How much energy do you need
to cool it? Not a lot.
Not a lot?
Not a lot. Making liquid nitrogen is liquid nitrogen is cheap. It costs like milk, even less than milk. You know, there is a beer scale, and it's less than beer. Yeah.
So I mean,
So
it's not obviously like a perpetual motion machine, but
no, it's not. Definitely not.
you have to keep it.
You have to keep it
So
cool.
that's the problem. That's the flaw in the ointment. How do you keep large quantities of coolant?
Can you touch this? Is it cold?
Yeah.
No, it's not. Just metal.
It's not cold.
No, it seems. Yeah, you're right. It seems
Not as
because
cold
it's
as what's
metallic.
inside, though.
But it's not cold, and inside is minus 321 degrees cold. So insulation, thermal insulation is not a problem. There are other problems, definitely, but not the isolation, not the cooling. Okay? So let's see if it works. I'm not sure it will work. So,
Okay, what are we trying now? Why
so
you keep
what I did is I did a sandwich.
Okay.
Two wafers and the sponges between them.
Yeah.
Maybe it will work, maybe not. I'm not sure.
What? Because you want the sponge itself to absorb the.
I want the sponge to absorb,
absorb the
and I want the isolation to be better. So I don't want to. Previously, what we had two layers, one on top of each other,
Yeah.
and one isolated the bottom one, the top one isolated
Yeah, you didn't have the sponge in the middle? Oh, I didn't.
No, I had the sponge above,
Yeah.
but I had another layer that isolates. And Sapphire is it's quite a good
Now it's in the
isolator.
middle.
Yeah,
There you go.
it's much better. Okay. So again, it's wobbly because it's much farther away from the magnets, and it won't hold so as long as you see, because the liquid nitrogen has a problem getting inside. So we really need to soak it up better. But when it's cold, it's stronger. So you
Now, what
really-
is that? What is within that again? What was
What? Sorry.
That's the clouding area.
Right
What is
here?
it? Yeah, what is that in there? In there.
Inside is liquid nitrogen, which is
Oh, and these are the vapors.
the vapors are two things. It's it's oxygen, which liquefies at higher temperatures, at high temperatures than nitrogen. And there's also moisture in the air, which liquefies.
Water vapor.
Water vapor.
Can I touch it?
Yeah.
4 millimeter.
So you can change it. But you have to give it the first nudge.
Yeah, because it doesn't move itself. It can move without any friction, but it doesn't. You still have to move it.
Give it the
But why
first.
can't you tilt it though? It stays and it locks.
I can do it
Then why?
because it's locking. It's not the.
That's when that's the whole.
So what are the
then you know it's not
I
applications?
think you already failed. So I'm going back to the.
I don't think it did. You still didn't do what I said, but that's fine. You can't do it.
It still failed.
Tell him again.
I want the two discs on top of it. I want the two discs on top
Accept
of it.
failure. Don't reject failure. So I'm joking. So I'm going to go back to the previous.
The initial study.
Yeah. And this is a little weaker, but thermal isolation is better, and it always touches the liquid nitrogen, so it holds longer. And because I can punch it now on the top, and I can feel it with liquid nitrogen better.
Oh, hi. Okay. Very good.
Let's wait until it's.
You're leaving tonight? Oh.
Okay.
Yeah, I'm gonna go. I'm gonna go right away. I'm gonna come soon. All right? Yeah.
And if I push
Gloria
it
said she'd be there
further,
like
I
6
can make it
o'clock.
move.
Oh,
We're supposed
faster.
to meet at 6
Faster,
o'clock.
yes.
Okay?
Staying at one level.
And it
All
will
right,
move until
okay,
it warms
right.
up.
How about on the other one?
This one?
No, on the.
Oh, I can do it.
Wait, so do you want to show that it holds something like this?
Yeah, of course.
Okay. Go ahead.
Sorry.
Yeah, that's nice.
Yeah, but that weight is now on top of the table. Yeah.
Yeah, the table holds both the weight of the disc and the.
Whatever. And then the four.
So what are your...
What?
It's on the table.
Yeah.
It's not being pushed up by the magnet.
No. It's being pushed up by the magnet, but the magnets are being pushed by the weight of.
Okay.
Yeah.
Okay.
Could you hold this bottle?
No, not in this configuration. If I put two together, I could.
If you set it in a dish of liquid nitrogen, would the plastic interfere with the conductivity?
No, the plastic
Or so that
doesn't do anything.
so it would just go as long as that dish of nitrogen lasted?
Yeah.
Yes.
So if you were to
Yeah, exactly.
have a car on top of that car's weight would be on the table and then on the ground.
You mean like this? And
Filled with nitrogen?
yeah, but what would happen? The dish will just drop.
At the end, you mean?
No, at the beginning, like this. You need to rigidly put this together, so there'll be one
So it holds it
object.
up. It
Yeah.
bears the weight of it.
Yeah.
We tried all kinds of
So what are your applications for this?
I know.
So specifically for these superconductors, it's just educational demonstration, and we want to, send this to every high school, every university. This is for these superconductors, but in the future, we're going to scale
Wait, you
this.
patent that?
We have patent on the fabrication, but it's not practical. Currently, it's not practical to make it larger. So we need to find other strategies, other fabrication techniques to make larger superconductors in different shapes, thicker superconductors, and that's another thing I'm working on. Probably in a few years you see larger demonstrations, I hope. Maybe next
Wait,
year.
and the applications are the important thing.
So the
right?
applications are trains, basically.
What
Trains.
about cars?
Cars, it's more of a I don't know, far dream, because you still need the magnetic rail. And so you need to pave the road with
Would
magnets.
that be wonderful?
It would be great.
And there would be no accidents?
I'm not sure about the accidents. The accident would be more lethal.
Yeah.
Because you can move in much higher speed. So
If this was applied to a train, would it be difficult to control its speed?
no. There are well-known techniques to accelerate electronically electronically train and decelerate and decelerate to stop it. Again, electronically. So this technology is well known. It's not related to superconductors at all. It's just electromagnets and so on.
It's amazing to see it on top of us, Steven.
Do you have kids?
3 kids.
Do they think Daddy does magic?